So here's a question. A mechanic lifts a 140 kilogram engine off of the ground at a constant speed of 3 meters per second. After the engine has been lifted 2 meters, how much work is performed by the mechanic? Okay, so to solve this type of question, we need to use the concept of work. Work is defined as a force times a displacement multiplied by the cosine of an angle in between the force and the displacement vectors. It's important that you use the angle in between the force and the displacement. So what I like to do is first draw a picture to visualize what is happening in this scenario. So we have a mechanic who's lifting an engine that just happens to look like a square. Now he lifts this engine up 2 meters above the ground. Now the next thing that I like to do is to draw a free body diagram so that I know what forces are acting on the system. So we have this applied force that goes upwards because the mechanic is lifting the engine off of the ground. We also have a force acting downwards. This is the force of gravity. Now, after we label our forces, we need to decide how we're going to solve this problem using work. Now, there's two ways of doing this. We can easily use the work equation, or we can resort to using the work energy theorems. Let's start off by using the work equation. So if we recall, work equals force times a displacement times a cosine theta in between the force and the displacement vectors. Now if we take a look here at this diagram, we want to know how much work is performed by the mechanic, and the work that the mechanic performs is going up this way, which is the applied force. Now, the distance is 2 meters. This is how much it displaced. And the angle in this scenario is 0 degrees. Why? Let's draw this and rotate it for just a moment. So if we have the engine right here, and we have the displacement going up, we have the applied force going this way, and recall that it displaced 2 meters, so 2 meters. We need to find the angle that's between the force and the displacement. So it displaced 2 meters, and the force is going this way. Therefore, the angle is right here. And since they're both in the same direction, because the displacement vector is going upwards, as you can see, and the applied force is also going upwards, they're in the same direction. So this is a 0 degree angle. Now cosine of 0 is just 1. So now let's plug everything in. We have a displacement here of 2 meters, and we have our angle cosine of 0. But what about the force? We can't easily find the force, but we can find it by using Newton's second law. So now we'll stem away from using work, and we'll focus our attention on the forces in the y direction. So we want to sum up the forces in the y direction. Hold on, I'm gonna give myself a little bit of space here. So when we focus on the forces in the y direction, we have to sum all of them up. And we have our applied force minus our force of gravity. And that's equal to our mass times the acceleration in the y direction. Now, the question is the object accelerating? The object is not accelerating, and this is because of this statement right here. A constant speed of 3 meters per second. If it's going at a constant speed, that means it is not accelerating. Now we can go over to this portion of our equation. And this all becomes 0 because the acceleration is 0. It doesn't matter what the mass is. This part right here just becomes 0. So now we can further solve our equation. We can say that our applied force minus the force of gravity is equal to 0. We can even say the applied force is equal to the force of gravity. And all I did there was move this term to the other side of the equation where it was 0. Now, I can rewrite Fg as mg because the force of gravity is the mass times gravity. So our applied force, this portion right here, is equivalent to the mass of the engine multiplied by gravity. I will erase it right here. We said that the mass was 140 kilograms. And we said, and it is given that the acceleration of gravity is 10 meters per second. Ultimately, the final answer we would get for our applied force would be 1400 newtons. Now we can take this value and substitute it in right here. Now we can solve how much work is performed by the mechanic. I'm going to erase this section right here. So this is 1400 times 2.0 meters times the cosine of 0. The cosine of 0 is just 1. So we have 1400 times 2 meters. And we're left with 2800 Newton meters. Now, a Newton meter, for when it comes to work, is a joule. So for part A here, the answer is 2800 joules.